Advanced equations. What we're going to do is get the variable by itself using the inverse operation. So isolate means get the variable by itself. So these first few questions are just review. What we're working towards is how to handle fractions. So let's just remember a few things here. In general, the last thing you do is get rid of the coefficient. The coefficient is the number in front of the variable. In this case, it's a 5. So that's the last thing we do is get rid of that coefficient. So to get the variable by itself, first of all, I'm going to get rid of the 3. So I've got 5x equals negative 2 minus 3 is negative 5. Be aware here, you can get fractions on any of these questions. We're going to divide by 5, and negative 5 divided by 5 is negative 1. So in our first question, we get negative 1. For our second question, the key thing is to remember one of the number one rules in algebra is whenever possible, you need to simplify. Simplify whenever possible. So here I've got like terms on this side. I'm looking at this side. What can I combine? 9x minus 4x is 5x. Negative 3 minus 2 is negative 5. And negative 5 plus 5 is 0. I like that. 5x equals, and 6 plus 4 is 10. And now I can just get rid of the 5 with the inverse operation. This is 5 times x, so I'm going to divide by 5. Inverse of multiply is divide. And 10 divided by 5 is 2. For this last one, this brings up one of the common errors in algebra, and that is whenever there's a minus in front of parentheses, like here, that minus has to be distributed. It's like distributing negative 1. But in this case, you have to understand really what we're going to do is distribute negative 2. So this is going to be 32 equals 36. Now this is a negative 2 times negative 1, which is a positive 2. And then a negative 2 times a negative 1 again, which is a positive 2w in this case. And again, that number one rule, whenever possible, simplify. So we've got 36 plus 2. This is 32 equals 38 plus 2w. Let's bring this up here. Now, I'm going to get the variable by itself, which is the w. The coefficient is the last thing I do. So I've got to get rid of this positive 38. There's a 38 added to the 2w. Well, the inverse of addition is subtraction. So I'm going to subtract 38 from both sides. 32 minus 38 is negative 6. So negative 6 equals 2w. And I got a coefficient of 2. That's 2 times w. So I'm going to divide by 2. Inverse of multiply is divide. And I can see that w is negative 3. Now, notice I flipped it around. That doesn't matter. You don't need to. Either way is fine. At last, the advanced equations. The thing I want you to know here is how to get rid of fractions. The way you get rid of fractions is you look at all your denominators and you choose the least common multiple, and you multiply everything by that least common multiple. So the common multiple, by the way, is the same thing as the common denominator. So in this case, the only denominator is 2. I'm going to multiply both sides by 2. Here the 2's cancel. Remember, this is 2 over 1. It's up top. To cancel, you need multiplication between them, and you need a number above and below because there's multiplication and division between them. So this ends up being 3x equals 42. And now I can divide by 3, and 42 divided by 3 is 18. So here is a better example. I'm looking at the upper right. I'm looking for the common multiple of 3 and 4. Multiples of 4, 4, 8, 12, 16, 20. Multiples of 3 are 3, 6, 9, 12. Well, 12 is that common multiple. By the way, notice 3 times 4 is 12. That'll always work, but it won't always give you the least common multiple or the least common denominator, if you want to think of it that way. So I'm going to multiply each side by 12. And here the 3 and the 12 cancels. And remember that 12 is up top. 3 goes into 12 4 times. 4 times 2v is 8v. V, not W. Here 4 goes into 12 3 times. This is negative 2 times 3, which is negative 6. And I'll divide by 8. Now, the rule is every fraction needs to be reduced, or in simplest form. And the way we reduce is we find the common factor above and below. Well, 2 divides into 6 and 8. So I'm going to divide both of these by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. I get an answer of negative 3/4. This next example, I need to simplify. It's always good to simplify before you do anything else. And notice the double negative. Minus negative 2 ends up being plus 2. So negative 10 plus 2 is 8. Now, my common multiple is, the only denominator actually is negative 12. So I'm going to multiply everything by negative 12. And these cancel. And negative 8 times negative 12, two negatives. When you multiply, make a positive, and that's 96. This next one is pretty much the same as the first one. Again, my only denominator is 3. I'm going to multiply by 3. 10x equals 90. And I'll divide by 10. And x is 9. Now, this is a better example because it illustrates that you have to multiply everything by your common denominator. See, the only denominator or multiple is 5. The only common multiple we have in our denominators is 5. So I'm going to multiply each side by 5. But it's very important you understand, over here you have to distribute. You have to take 5 to everything. Well, these cancel, and I get a minus 5 times 5 is 25 equals negative 5. And I can add 25 to both sides. Inverse of subtraction is addition, so I added 25. And negative 5 plus 25 is 20, so x is 20. Here's where it starts to get a little bit tougher. See, I have 3 denominators here, 8, 48, and 3. And what I want is the common denominator, the least common multiple. Well, what I usually do to find that common multiple is I take the largest number, and I'll take, in this case, 48. I'll take multiples of 48. And what I'll try to look for is the first one that 8 and 3 divide into. Well, the first multiple of 48 is 48, and 8 and 3 both divide into 48. So 48 is our common multiple. So I'm going to multiply everything by 48. Eight into 48 goes 6 times. That's 6x. The 48's cancel, and I get plus 1. 3 into 48 goes 16 times. Negative 1 times 16 is negative 16. So I'll take a 1 off each side. 6x equals negative 17. And I'll divide by 6. Now, 17 doesn't divide by 6, and 17 and 6 have no common factors. So my answer is negative 17 over 6. This next one, I need the common multiple of 2, 4, and 6, the common denominator of 2, 4, and 6. Again, take your largest number, 6, take multiples of 6, 6, 12, 18. Find the first one that 2 and 4 divide into, and they all divide into 12. So I'm going to multiply everything by 12. Don't forget the 2. Every term gets multiplied by 12. And terms are separated by addition and subtraction. So because there's a plus between the 2 and the 1/6x, they're separate terms. It's like you're distributing. I'm taking 12 to everything. You are distributing. Here, 2 into 12 goes 6 times. 6 times 7 is 42x. 4 into 12 goes 3 times, so 3 times 1. 2 times 12 is 24. 6 into 12 goes twice, so that would be plus 2x. There's variables on both sides. Now, I'll get a lot of students here that try to subtract 3 or subtract 24 to get rid of the constant, the thing that's added. But you're always better off doing the variables first as a rule. So get the variables on one side, get rid of one of them, either subtract 42x or subtract 2x. I like to keep things positive. So I got 40x plus 3 equals 24. Now I'll subtract 3, and I get 40x equals 21, and I'll divide by 40. Now, 21 over 40 is my answer. Is there any common factors? Well, the only factors of 21 are 1 and 21, but 3 and 7, and none of those divide into 40. So my answer is 21 over 40. Ran out of room there. Ooh, this next one's a little tougher. The common multiple of 7, 10, and 28. And I believe maybe I think I'll just use 280. Notice that's 10 times 28. 27 goes into 28 4 times. There might be a smaller one, 140. But 280 would work, and it's not going to matter either way. Let's just use 280, because let's just say I didn't notice the 140. So I'll multiply everything by 280. The only difference is you might have to do a little more simplifying. But 7 into 280 goes 40 times. 40 times 2 is 80x. 10 into 280 goes 28 times. 28 into 280 goes 10 times. And 10 times negative 1 would be negative 10. Now we can subtract 28 from both sides, get the variable by itself. 80x is negative 38, and you're going to divide by 80. And as I mentioned, if you don't use the least common multiple, or the least common denominator, you're going to have to do some more simplifying. 38 and 80 at the very least are both divisible by 2. Let's see, that would be negative 19 over 40. And I believe that looks good to me. So on this next one, a little bit quicker, the only denominator is 7. So I'm going to multiply everything by 7. These cancel. I get negative 8a minus 56 equals negative 40. And I will add 56 to both sides. So this is negative 8a equals 16. And divide by negative 8. And x will be negative 2. Last few examples, some more fractions and things to point out here. And at the bottom, we're going to talk about what makes a no solution and what makes infinite solutions. So quickly here, first thing I want to do on this question is distribute. So you don't want to try to get rid of fractions until you distribute. In fact, you can't do it reliably unless you simplify everything first. So I'm going to distribute that negative 2. Remember that negative 2 is negative 2 over 1. So I'm only taking negative 2 times the top of the fraction. That would be negative 8/5 x. And then negative 2 times 3 would be negative 6. Now I'm looking for the common multiple of 3, 2, and 5. Now those are all prime numbers, so the common denominator is going to be 3 times 2 times 5. And in fact, whenever the GCF of the numbers is 1, the greatest common factor is 1, that's always going to be the case. You just multiply them all. So 3 times 2 is 6, 6 times 5 is 30, so 30 is what I'm going to multiply everything by. So I'm multiplying everything by 30. 3 into 30 goes 10 times, so that would be 10x. 2 into 30 goes 15 times, so that would be 15 times 1, so plus 15. 5 into 30 goes 6 times. 6 times negative 8 is negative 48. And then I got to take 30 times 6 also. That'd be negative 1. Oh, forgot my x. Negative 180. Now I'm going to get the variables on both sides, so I'm going to add 48x to both sides. So this is 58x plus 15 equals negative 180. Let's take a 15 off each side. So we got 58x equals negative 195, which is going to be a messy answer. Divide by 58. And the question is, does this simplify? I think that is your answer, negative 195 over 58. Reminder that if you get with a weird fraction and you can't find anything that divides into the top and the bottom, you can always use a calculator to check your answer and make sure that's reduced. In Desmos, you just punch in the 195 over 58 and then hit the little fraction bar, and that'll double check and make sure you're reduced. Graphing calculators can reduce those too. You just got to find the right keys. Last bit of fraction work here. Common multiple of 2 and 4 is 4, so I'm going to multiply everything by 4. Now notice the way I do this. I'm going to take 4 times this. That's one thing. The fraction bar groups it. It's one term. Multiply by 4 and multiply by 4, both sides. So here the 4 and the 2 cancel. You get 2, and you have to distribute that 2 through the parentheses. So that's 2w minus 2 minus 12. 4's cancel, and it'd be w minus 3. So that is 2w minus 14 equals w minus 3. Always simplify anytime you can. There are variables on both sides, so I'm going to take a w off each side. W minus 14 equals negative 3. Now I can add 14, and w will equal 11. So for these last questions, there's basically two scenarios that you get in. If you get an equation that's something like, say, x plus 1 equals x plus 1, any number, this is just an example here, any number you plug into that is going to always make it true. And in this case, there's going to be infinite solutions. In WAMAP, they're going to have us put the infinity symbol, which you can just type 2 lowercase o's. But what we would say, our book would prefer the answer of all reals. Basically, any number I plug in this will make it true. So that's all reals. The second scenario is if you end up with something like x plus 1 equals x minus 3. Now, you can't take the same number x and add 1 to it and subtract 3 from it and ever expect them to be equal. You can't make that true. I don't care what you do. So if the two sides end up being the same, like x plus 5 equals x plus 5, that means all numbers work. But if the two sides end up being the same variable term, but you have different numbers added, that's never going to work. That's a no solution. So look for this because this will pop up every once in a while. You get an equation that just doesn't have an answer. Can't take the same number, add different things to it, and make them equal. Impossible. So in WAMAP, we'll use infinity for all reals, and DNE for no solution, does not exist, is what that stands for. So it's just a matter of distributing here and combining like terms. These look like they're long, but they're really actually very short. 4 times 6, we got 24 plus 20 plus 10x plus 25 equals 34x plus 51. And we'll combine like terms. 24, I forgot my x. 24x and 10x makes 34x. 20 and 25 makes 45. And look, each side, the variable term is the same, so you've got the same number there on each side, 34x, but you're adding different things to it. You're adding 45 and you're adding 51. Those will never be true, never be equal. That's a no solution. So no solution would be my preferred answer. In WAMAP, you're going to put D and E does not exist. There's no answer. So for this last one, same deal. We'll distribute 24x plus 24 plus 16x plus 16 plus 2 equals 40x plus 42. And again, we'll combine like terms, 24x and 16x, that makes 40x. 24 and 16 make 40, plus 2 is 42. Look at that, both sides are exactly the same. So I have the same variable term, so any number I plug in for x is going to make the same thing. 40x and 40x on both sides will be the same number for any x I plug in. And I'm adding 42 on both sides. So this will always be true. This has infinite solutions. So as I said, our book would prefer the answer of all reals. In WAMAP, type a double O and you get an infinity symbol. So all reals is our answer.